All right, number 5. An algebra student has won $100,000 woo, in a lottery and wishes to deposit it in a savings account in 2 financial institutions. One account pays 8% simple interest, but the deposits are insured only to $50,000. The second account pays 6.4% simple interest and deposits are insured up to $100,000. Determine whether the money can be deposited so that it is fully insured and earns annual interest of $7,500. We have 2 things that we are hoping to accomplish with this investment. What are the 2 things that this person is interested in? Interest. How much? $7,500 in interest. So that is one of the things that they want to happen. What else do they want to make sure of? They want to make sure that it's all fully insured. So let's break this down a little bit, chunk it into pieces so that we can then write it in math and answer the question. Yes, sir.
Okay, so on a test, say we had a problem like this, and we just have no idea like what it is because we're not familiar with that. What would we do then?
If you are not familiar with like the context that it's in, you're going to raise your hand and you're going to ask me. Because if you're not familiar with a particular context because you've never been exposed to it, you've never had experience with it, I want to make sure that you have the proper background knowledge to be able to do that. Absolutely. It should never be, I've never interacted with this thing, so I don't even know how to begin. That's why you can't do it. That being said, I want to make sure that we get enough practice in the types of contexts that I might be presenting you with moving forward. So, what is simple interest? Okay. Yes, thank you. I'm sorry, one more time for me.
The rate that's on a fixed amount and it never changes after.
Yes. So these 2 banks that the student is interested in probably don't actually exist in real life. Real life banks don't pay simple interest. They pay you interest on usually a quarterly basis, and they take that money and they deposit it in your account, and the next time they go to calculate how much interest they're going to pay you, they look at what's currently in your account and they pay you interest on that. That is compound interest. We're dealing with simple interest here mainly because we're not trying to gum up the mathematics of it. We just want to work with a straightforward percentage multiplied by an amount to figure out how much that interest is. Does that make sense? Okay, so simple interest, once I calculate this value, that is what would be paid every single year, regardless of the balance in the account from that point forward. What does it mean for it to be insured?
If it's stolen, it will be given back.
If the bank is robbed, if it's stolen, it would be reimbursed by whoever this insurance company is. You guys familiar at all with the Great Depression?
Yeah.
Okay, so this is why we have federal insurance on deposits in banks. When the stock market crashed in the Great Depression, there was a rush on the banks. People are like, I want my money. And the banks are like, well, we don't actually have those bills. We don't have that gold. It's kept track of on a ledger. And there ended up being big problems with people not being able to get their money that they had entrusted to these banks. And that had to do with then the banks were taking their money and investing it in the stock market, and then they lost. So after that, the federal government said, in order to reestablish trust in the banking system, we will guarantee that deposits up to this amount will be insured. If there's a rush on the bank, if the bank says they don't have the money, we as the federal government will pay that money. You can trust this, you can rely on this. So that's what it means for it to be insured. Bank A here, since we don't have names for them, I'm going to call it Bank A and Bank B. Bank A's deposits are insured, but only up to $50,000. Why would you invest in this bank then? Interest is higher. It's a riskier investment, so it's not insured for as much, is this idea. Most of the time when we're looking at you investing your money, that rate of return, the higher it is because it is a riskier investment. You have a chance of making a lot in interest, but you also have a chance of losing stuff if we're comparing this to real world situations. Here we've kind of taken and simplified this concept down, and we're just assuming that they pay 8% all the time reliably and dependably. But they only insure up to $50,000. What's going on with this second bank? 6.4% interest, and they go up to the entire winnings for this student. So why don't they just put all their money there?
Because you won't be insured.
We'll have it all insured.
It won't gain as much interest.
It won't gain as much interest. How much interest would we gain if we invested it all there? I'm just going to hypothetical off to the side. If all the money went to Bank 2, would it be fully insured?
No. Well, yes and no. After you get the interest amount, no.
We're just assuming 1 year right now. So fully insured, at least for that very first year, yes. Because the idea is after the first year, they could take that interest amount out, put it somewhere else, and that original amount is still fully insured. How much interest would they get? 6.4% of what? 100,000. How do I find 6.4% of 100,000? Yeah, 0.064. Multiply that by 100,000. Feel free to grab your calculators for this one.
Will there be a question test?
It's possible, but the numbers wouldn't be so difficult to calculate without a calculator. So concept-wise, is it possible? Yes. Mechanics-wise, I'm not going to hand you something with this many decimals in it and ask you to do it in your head.
Okay.
It would be $6,400. Is that enough interest? Nope, not enough. So we're going to have to invest in Bank 1 if this is going to happen. Let's figure out how much would need to go into Bank 1. I know not all of it can, right? Up to half of it could go, right? All right, so let's think through this. Half in Bank 1, half in Bank 2.
Why don't you just open up 2 different bank accounts and put them both in bank 1?
Not sure. I can say, though, that this model for question style and these types of constraints, they do show up a lot in the real world where an answer as simple as that, unfortunately, doesn't work out. I wish I could point to a specific example off the top of my head, but I have Friday brain right now. I'll see if I can think of a good one over the weekend as far as when we would run into these types of constraints. We're just opening up 2 accounts at the same bank. Couldn't happen. All right. So if we put half the money in Bank 1, we would have $50,000 at 8% interest. Would that be fully insured?
Yes.
Yes, okay. Fully insured, yes. What is the interest on that then? How do I find the interest on that? 0.08 times $50,000, which would be how much?
I have a question.
Yes.
For the first one, why did you do 0.064 and not 0.64?
So when we're talking about percent, that's a great question. Percent is a compound word. 2 words that have been smashed together and now we use as just one word together. It is made up of the root words per, for for each, for every, and cent, which is 100. Like we have 100 cents in a dollar. So when we say percent, we are saying out of 100. So I would take that 6.4 and to return it into its decimal form, it is 6.4 out of 100. So I divide it by 100, which is going to move my decimal point 2 places. But that's why that is. Yes, sir.
Interest would be 4,000.
4,000. Yep. So we can get $4,000 in interest from Bank One if we put half of it there. We're going to do $50,000 at 6.4%. Fully insured, we're still good there. How much interest would we get?
3,200.
Yeah, 3,200. It's going to be half of the other interest, right? 0.064 times 50,000. And I get 3,200. So what would our total interest be then?
7,200.
Is that enough? So what does that mean?
It's not possible.
It's not possible. I want to work off to the side so that we know how to set up and solve how much we would need to put in each bank. We know right now that it's not possible. If I max out what would be insured at Bank One that has the higher interest rate, I cannot get to $7,500 in interest. So it is not possible. I'm going to go ahead and write that down. Not possible to be fully insured and get $7,500 in interest. Altogether, we're looking to invest how much? $100,000. I'm going to look at what we did on this 50-50 split and see if I can use that to write some equations that we could then solve as a system if we wanted to find out how much risk we would need to take if we wanted to get $7,500. We know it's not possible for it to be fully insured, so it's not going to work out for this student to get what they want. How can I write an equation that would describe the total amount of money to be invested?
Oh, would this be like x plus y equals xy, and then the other one would be like 0.1x plus 2.5y equals that.
I like it. X plus y equals, what do we want x and y to mean here?
In this case, x and y would be 100,000.
They can't both be 100,000. What is it that we don't know here?
The amount.
The amounts that are going into
Bank account.
each bank. So X would be the amount that we're putting in one bank, and Y would be the amount that we're putting in the other bank. So I'm going to let X be amount in bank one. And Y is going to be the amount in bank two. If I take the amount that we invest in bank one and the amount that we invest in bank two, assuming we're investing at all, it should add up to how much?
700,000. Wait, 100,000.
100,000, because that's the investment. That's not our interest, that's our investment. So it's going to add up to 100,000. So that's the money to be invested. What else are we concerned about in this problem? The interest.
0.08x.
Mm-hmm.
0.064y.
Yes, 0.08x plus 0.064y equals 7,500. And now I can solve this like a system. We've got three methods for solving systems of equations. Graphing is one of them. I think that's a horrible choice for this particular problem. Elimination, what's the other method? Substitution. I heard we want to use elimination here.
You can't really substitute in the...
You can.
Well, not right now.
No, not right now. You would have to solve that top equation for either x or y, and then you could substitute in fairly easily. You could have 100,000 minus x or 100,000 minus y and take that and put it in. I'm perfectly fine using elimination or the linear combination method. How would I go about using that method?
Multiply the top one by -0.08.
We can multiply the top one by negative 0.08. Okay, so then I would have negative 0.08x minus 0.08y equals negative 8,000. All right, I'm going to add these two together. My x's will cancel for me. I have negative what y? You can grab your calculators if you need to. 0.016 y equals negative 500. And then I would need to divide 0.016, negative 0.016. And I get that y is what? You are welcome to grab your calculators for this, by the way.
How did you get negative 8,000?
Negative 500.
This right here.
I think of it like
So those,
This.
are those multiplying?
Yes.
Oh.
It's
Yeah, sorry. Multiplying this by those values. Yep.
that.
What would I get?
That one.
3,125.
I'm sorry, how much?
3,125.
3,125.
well, it's almost there. I probably just like added
Make it a 0.
I feel like there's a zero missing.
Yeah, it's 31,205.
Yeah, 31,250. Yeah, there we go. Okay. So that's how much we should put where? Bank 2. How did we decide it was bank 2 and not bank 1? Yeah, we canceled X for bank 1, so this would be amount in bank 2. So how much should we put in bank 1 then, if we were going to get $7,500 in interest?
Wouldn't it just be
$100,000 minus 31,250. And that's what, 68,750. So more than 18,000 of it would be uninsured if we were going to get the interest amount that we wanted. $18,000 uninsured. I'm running out of room on my screen. There's too much to fit on here. 18,000 uninsured. All right. Yes. Oh, sorry. You were taking a picture. I thought your hand was going up. All right. Let's look at another one that uses a similar setup as far as the system is concerned, but doesn't deal with any percentages.
Okay. Because that was a lot.
It was a lot.
That was meant to be streaming.
This one should feel more like Algebra 1, Algebra 2.
Literally have to figure out lots of items,
We need to make sure that you guys know how to set up and solve system of equation story problems. 600 people attended the premiere of a motion picture. Adult tickets cost $9 and children's tickets were $6. If the box office receipts totaled $4,800, how many children attended the premiere?
5.
How many unknowns do we have?
A lot. 6, 9,
2. What are my 2 unknowns? How many adults, how many children? What should we use to represent those unknown values? A and C, X and Y. A and C is the first thing I heard. If you want to use X and Y on your page, I'm totally fine with that. I'm going to use A and C because, again, it's just the first thing I heard. So what would A represent here then?
Adult.
What about the adults?
Adult tickets.
Adult tickets, so yeah. The cost?
No, just
No. Yeah, the amount or the number of adult tickets. When you're defining variables for me, I'm okay if you don't write full sentences, but make sure you include all the important information. If you just say A is adults, I'm going to know what about those adults, because we want to make sure that we're interpreting our answers correctly. C would be number of child tickets. If I have 2 unknown values, then I'm going to have at least 2 equations in order to be able to solve this. What are the 2 pieces about this movie premiere that we know?
The number of people that came and then told how much money.
Yeah.
Yeah.
So I'm going to write an equation about people, and I'm going to write an equation about money. What do we know about the people that attended? There's 600, and it was made up of what type of people?
adults.
Adults and children. So all the adult tickets plus all the child tickets should add up to 600 tickets, or else somebody snuck their kid into this show without paying. What do we know about money?
Total out to 4,800.
Totaled up to 4,800. What do I know about adult tickets and money?
Costs $9.
$9. So 9 for each adult ticket, 9A. That would give me the total amount that was brought in by the adult tickets. What do I know about child's tickets and money?
There's $6 each.
$6 each. So 6C would give me the total amount of revenue that was brought in by the child tickets. So I have the total amount from the child's tickets plus the total amount from the adult's tickets gives me the grand total $4,800. So far, so good? Very similar setup as far as my equations to the last one, without the decimals. We used elimination last time. Just for practice, let's use substitution here. I would, if I'm going to use substitution, I would use this top equation because that looks a lot easier to get a variable by itself. And I'm wanting to know how many child's tickets. That's what the big question was, right? So I'm going to solve this for A, because that means I'm now going to take this value and replace the A in my second equation, leaving me only the value of C, which will tell me how many children attended. So I'm going to take this right here. It's going to take the place of this A right here. So I would have 4,800 equals 9 times 600 minus C plus 6C. Use my distributive property here. What's 9 times 600? 5,400. 9 times 6 is 54, and then I just pop those 2 zeros on the end. Minus 9C plus 6C. Where would I go from here? Combine the c's together. That's going to give me negative 3c. I'm going to subtract 5,400 at the same time. $4,800 minus 5,400. Negative 600. So then I divide both sides by negative 3. And I get that C is what? C is 200.
I'm gonna verify a question.
Give me just a second. Come on in. Have I answered the question?
No.
What would answer the question?
Stating.
Stating it. What should my final answer be?
200 children attended.
200 children attended. Which means how many adults attended? 400. So there's a 2-to-1 ratio on adults to kids. Means like 1 kid, 2 parents going to this movie premiere.
Oh, at least they have 2 parents.
Or at least 2 adults that showed up.
Well, yeah, we should do that.
Yes, you did. That is correct. All right. You're welcome. Number 7. See if we can actually get through these. We got 3 problems to go. 2 children who are 224 meters apart start walking towards each other at the same instant at rates of 1.5 meters per second and 2 meters per second, respectively. So I'm going to draw a little picture of this so that I can wrap my head around what's going on. I've got 2 children. Are they side by side? No. Opposite sides. What do we know about these 2 kids? One is faster. Which one's faster?
The red one.
Okay. 2 meters per second. We'll make the red one faster. He's going this way. Or she.
Or they.
Or they. Very valid. What do we know about the other kid?
They are slow.
And they're going this way?
No, they're going to.
They're going towards each other.
They're going towards each other. So I got to turn this around.
They're about to fight.
1.5 meters per second. I like to think that they're like getting together to play, not fight. But, you
I
know.
think that the 1.5 should be.
What else do I know about these 2 kids? 224 meters apart. And what do I want to know about these kids? When will they meet? If I'm answering a when question, I'm looking for what? I want time. Yes. Find time in seconds. And if they are meeting, what do we know about their distances at that time? It's going to be the same, right? They're going to have the same, like if I was looking at like something like the Monon Trail where they have these 1/4 mile markers, they're going to be at the same location at that point. So I'm going to need a variable. What should my variable be? T. I'm going to use T for time. T equals time in seconds. You are welcome to use whatever you want as a variable as long as you define it for me. Just tell me what it means. If these kids are going in opposite directions,
One has a negative because negative direction.
love it. Love it, love it. So one of these we're going to have to describe as a negative speed. Even though speed isn't negative, they're moving in the opposite direction. So we're going to think about it like it's a negative speed. I also need to know their relative starting locations. If I'm thinking about this, I've got rates. I need starting locations. That's like slope and y-intercept. Right?
0.
0 and 224. Who's my 0?
Red one.
Red one sounds good. And then over here would be 224, and I want to know when they meet. So when their distances are equal. Talk to me about the child that I drew in red. How would I write an expression to describe how they are moving through space? 2x. Or in this case, 2t. Yep. Because I use t for time. If you use x for time, that's fine. What about for the child that I drew in blue? 1.5t plus 224. Almost. Negative. Why negative? Yes. So we have opposite direction. And where'd the 224 come again? Yeah, this is our starting location. Or if you want to think about it as a y-intercept, that's not an inappropriate way to think about it. Where do I go from here? Add 1.5t to both sides. So I have 3.5t equals 224. Divide both sides by 3.5. And t is 64 seconds. So to answer the question, they meet at 64 seconds, or 1 minute 4 seconds. Either one of those would be correct. How far did each child walk?
Yeah.
How would I figure out how far child 1 walked? Yeah. Yeah. We know that our distance traveled is equal to the rate that you are traveling at multiplied by the time. If I'm figuring out how far someone walked, do I care what direction they're walking in? No. So I don't care that the one that I drew in blue is walking backwards. I just want to know how much ground they covered. So I'm going to take their rate and multiply it by the time. I'm going to do this for each child. So the distance would be equal to 2 times 64. How far did the child in red walk? 128 what? Meters. For child 2, they have a slower rate, so I'm guessing that they probably went just as far, farther, or not as far? Not as far. 1.5 times 64 would get me what? 96. So one child walked 128 meters. And the other walked 96 meters. Okay. Let's look at number 8. We might have to do number 9 on Monday. That's okay. But let's go look at number 8. In a certain medical test designed to measure carbohydrate tolerance. What are carbohydrates? Carbs. Yeah, this is compound sugars, right? Your body uses them for energy, things like breads, potatoes, starchy things.
Yeah.
Those are carbohydrates. Potatoes. I love potatoes.
Me too.
Just about any form.
Yes.
Sweet potatoes are.
No. They are very starchy though, so they still give you a lot of carbohydrates. They're not the same. When an adult goes in to take this test, guys, does anybody know what this test is like, just from the first sentence or two, what this is describing? Yeah. This is like when they test you to see if you have diabetes, or the opposite of diabetes, hypoglycemia, which is where your body processes sugar too fast. You have too much insulin in your body. This is the test that they give you. You will drink this glucose solution, this simple sugar solution. It is disgusting. I have done this. You drink this glucose solution. They give you the option. They say, do you want one that's like Sprite or one that's like orange drink? And it's a trick. Either way, it's a trick. It tastes like thick syrup.
Well, which one did you pick?
I've had to do it more than once. Because when you're pregnant, they have you do it because your body changes a lot and they want to make sure that you're still processing things correctly. I've done both of them and they're both horrible.
Which one was yours?
The Sprite-ish one.
For real?
Yeah, at least the orange one, there was like some kind of candy flavor to like, you could almost imagine that it's one of those kids things that's more like a squeezy whatever. But it was about that consistency. But yeah, like 7 ounces of it. No, thank you. Do you guys know how much 7 ounces is?
That's less than a Red Bull can.
It is less than a Red Bull can, but it's almost a cup. It's almost a cup of this stuff. And you have to drink it in a certain amount of time because you need like this sugar overdose in your system. And then what they do is they draw your blood periodically to see how much is still in your system.
Is it worse than cough syrup?
You know how cough syrup has like that burning feeling in it? This does not have that. It's the same sickly sweet flavor, but without that burning.
Okay.
Yeah.
I don't want
Okay. I figured out by my 3rd pregnancy that there's a way to do this with food. You do like a pancake breakfast with a bunch of syrup on it, and you drink orange juice. Foods with a certain amount of sugar in it.
That sounds amazing.
It has to be very specific amounts, and it's a lot harder to do, so the doctor's office prefers this stuff. I did not. All right. Okay, so this is interesting that they bring this up because the very first time I was tested for this, I was not an adult. They suspected me for hypoglycemia, and I had to go in as a child, which means you don't get the same dosage of glucose solution as an adult would. They get a slightly diluted version. Adults drink 7 ounces of a 30% solution. Children drink 7 ounces of a 20% solution. So there's, by volume, less sugar in it. It's still gross. It's just a little less gross.
But what if a child weighed like as much as an adult? Would they be considered an adult in that case? What if just an adult?
Not being a medical professional, I don't know, but I'm sure that it's based on a couple different metrics, probably height as well as weight. So they'd probably be looking at both things. All right, so I want to know, because the doctor's office just has this 30% glucose solution, and they are going to water it down to get the 20% solution that they need for the child. We're trying to figure out how much of this should be straight out of the bottle glucose solution and how much water are we adding in, because it needs to be precise on the percentages or else it throws their readings off.
70% water, 80% water, 20%.
How much volume is the child needing to drink? 7 ounces. So volume, we need 7 ounces, and that's being made up of what 2 things?
Water, glucose.
Water and glucose. Are you guys okay if I just do W and G?
Yes.
4 minutes left.
Yes, we do. So W is meaning what here?
Water.
What about the water?
How much?
How much? So amount of water.
Stay hydrated.
And what is G representing here? Specifically the amount of the 30% glucose solution. because we're getting ready to make another glucose solution.
The 30% either way is just the concentration. There has to be more water than the other one.
Yeah, okay, so I like that you said concentration, because that's the next thing I'm going to need to figure out. How much sugar is in this? When I'm thinking of this total volume that the child is getting ready to consume, how much of this 7 ounces is going to be made up of sugar? 20% of it. 20% of 7 ounces, right? So I'm going to do 0.2 times 7, because this will tell me the amount of sugar in the 7 ounces of the 20% of solution. All right, how are we going to get there? How do we get 20%, 7 ounces glucose solution? I'm combining what objects together? Water and the 30% solution, right? Do we know how much of water or 30% solution we're adding?
No.
But I can figure out how much sugar is being contained in this 30% solution by 0.3x. How much sugar is there in the water?
A lot. 30%.
In the water. How much in the water? 0. There is no sugar in the water. All right. We will finish this one on Monday, and we'll also do number 9 on Monday.